आपण ज्या SHM चा आतापर्यंत अभ्यास केला आहे that is ideal simple harmonic motion, ideal SHM, in which the amplitude remains constant and there is no loss of energy. म्हणजे काय की समजा सिंपल पेंड्युलम आहे, त्याला डिस्प्लेस केलं आणि सोडून दिलं, it is performing oscillation, then we have assumed that it is an ideal oscillation, means the amplitude of oscillation will never change. तो पेंड्युलम तेवढ्याच amplitude ऑसिलेट होत राहील कयामत तक, प्रलय आने तक, पृथ्वी नष्ट होईपर्यंत. It will keep on oscillating with the same amplitude, but that is impossible, isn't it? Because there will be friction. Due to friction with air and all, there will be loss of energy, and due to that loss of energy, the amplitude of oscillation will go on decreasing, isn't it? So in actual practice, the SHM with constant amplitude is not possible. In practical, the amplitude will go on decreasing. That is called damping. The loss of energy, the decrease in amplitude of oscillation is called damping, and the oscillations are called damped oscillations. The oscillations are called damped oscillations. So in actual practice, all the oscillations will be damped oscillations, but we study ideal conditions, so we have studied all the ideal oscillations where there is no damping. Now let us see what is damped oscillation. Damping जी होते त्याच्यामुळे काय इफेक्ट होतो. For that we take the example of a spring, and suppose a block is connected to the spring. When you pull this block downwards and leave it, it will perform oscillations. Ideally, the amplitude of oscillation will remain constant. But in actual practice, what will happen? Due to friction with air and all, the energy will go on decreasing. Therefore, the amplitude of oscillation will go on decreasing. कारण energy जी आहे, energy in SHM, formula काय त्याचा? Half m omega square a square. Since energy will decrease, means amplitude will also decrease, and the amplitude will go on decreasing in this case. त्याला आपण म्हणतो damping. The oscillation is damped oscillation. आता आपल्याला डॅम्पिंगचा अभ्यास करायचा आहे, तर डॅम्पिंग फोर्स थोडा जास्त पाहिजे, कारण इथं एअरमुळे जी डॅम्पिंग होणार आहे ती कमी असणार आहे. सो फॉर दॅट व्हॉट वी डू, a rod is connected to this block, and that rod is connected to a disc. अशी एक डिस्क आहे, right? The block is connected to a rod is connected to a disc, and that disc is in water. आता काय होईल? या पाण्यामुळे फ्रिक्शन जास्त होईल, म्हणजे डॅम्पिंग जास्त होणार, राईट? दिस इज द एक्झाम्पल वी यूज फॉर स्टडीइंग डॅम्प्ड ऑसिलेशन्स. बघा एकदा काय काय आहे तिथे. स्प्रिंग अँड द ब्लॉक. The block is connected to a rod, which is connected to a disc, and the disc is inside water, so that when you pull the block and leave it, it starts oscillating, and due to this friction, the damping will occur there, right? Now this damping force, FD, damping force is equal to minus BV. No proof, no derivations, nothing. Directly we have to remember the formula. Damping force is how much? Minus BV, whereas V is velocity of this block or any particle which is performing SHM, and B is called damping constant. B is damping constant, and the negative sign shows that the damping force reduces the motion. So opposes the motion. So damping force Fd is equal to minus bv. B is the damping constant, v is the velocity. हा डॅम्पिंग फोर्स आहे आणि ओरिजिनल जो फोर्स आहे तिथं ज्या फोर्समुळे ऑसिलेशन होतं दॅट इज रिस्टोरिंग फोर्स विच इज इक्वल टू मायनस के एक्स, राईट. सो नेट फोर्स ऑन दिस ब्लॉक विल बी इक्वल टू मायनस के एक्स प्लस मायनस बी व्ही. So net force is minus kx minus bv. Net force can be written as mass into acceleration. So this F will be ma, mass into acceleration, which is equal to minus kx minus bv. Correct? Or m, acceleration is d2x by dt square, you know this, is equal to minus kx minus b into velocity is dx by dt, right? So you can say that m d2x by dt square plus, minus the plus will, b dx by dt plus kx is equal to 0. This is the equation for damped oscillation. If you solve this equation, you get, you don't have to solve it, you don't have the proof. If you solve this equation, you get x is equal to ae raised to minus bt by 2m. X is equal to ae raised to minus bt by 2m cos omega dash t plus phi. This is the displacement in damped oscillation. Solving this equation, we get x is equal to ae raised to minus bt by 2m cos omega dash t plus phi. This is the displacement in damped oscillations. This ae raised to minus bt by 2m, this is the amplitude of damped oscillation. The amplitude of damped oscillation. A is the amplitude of undamped oscillation, and this ae raised to minus bt by 2m is the amplitude of damped oscillation. Exponential. You know what is exponential? Exponential increase, exponential decrease. जर इथं पॉवर प्लस मध्ये असेल, exponential raised to plus something, it is exponential increase. And when it is exponential raised to minus something, it is exponential decrease. Exponential decrease ही अशी असते. Exponential decrease म्हणजे ती zero होत नाही, कमी 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 होत जाते पण zero होत नाही. So this means that the amplitude of damped oscillation decreases exponentially because it is e raised to minus bt by 2m, means the amplitude of damped oscillation, it decreases exponentially. And the periodic time of the damped oscillation, it is given by t is equal to 2 pi upon under root k by m, in usual असतं, minus b upon 2m square. This is the formula for periodic time of a damped oscillations. Again, I am repeating it. No derivations, no proofs. We have to remember the formula. The period of damped oscillation is 2 pi upon under root k by m minus b upon 2m square. This shows that this factor there means denominator will go on decreasing, denominator will decrease, and since denominator will decrease, the period will increase. So as there is damping, the periodic time goes on increasing. So this is damped oscillation.